PIR, also known as passive infrared sensor, is widely used in motion detections. Now there are so many module types available that varies in pricing and sensing range. So due to commercializations, you may have the same brand but differ in performance. That really scratch your head. So the following video will clear up all this mess and tell you the secret on identifying a reliable module. Over here, we will make use of HC-SR501, one of the cheapest module, to tell you how it works. We will go into detailed analysis of module behavior in the later sections. Now let's take a look at the module. The front view portrays a dome lens and a hidden pyroelectric sensor underneath. The back view, shows a printed circuit board with two adjustable presets and a jumper setting. The first preset is to set the detection range. Now this basically is adjusting the amplifier gain. A good module can sense up to 7 meters without field, but most modules that I've encountered only works best at about 5 meters. The second preset is for you to set the output turn on time, is also known as TX. So this could range to several minutes. Then, the jumper is to enable whether the module will continue waiting for subsequent trigger or just work on a single trigger. Now let's dive in to see what is inside the module. The key of the stability lies on two components. First is a base chip. The next will be the pyroelectric sensor. So this will give the good range and the motion detection reliability. So a typical circuit will be as shown in this diagram. The base chip will manage the output with the preset and other electronic components. On the other hand, the PIR sensor output will be pumped into a two-stage amplifier controlled by the base chip. Now this coupling, though looks simple, but is very stable. However, one point to take note, the base chip will only start to work after a 1 minute warm-up time. The range sensitivity lies on a good pyroelectric sensor. So if the sensor is not sensitive enough, only weak signal can be produced. If that's the case, even with the highest amplifier gain, a stable signal can't be achieved. The sensor is actually made up of two separate sensors in it. With this, it can only detect radial or horizontal movement. In other words, it's only good to pick up radial motions. By having a sensor A and B placed side by side, the signal changes when someone walks or shifts from left to right. However, it still responds to vertical motion as no one can actually walk in a straight line. Now the secret behind the heat detections is actually on the focusing lens. Horizontal ray from far will be gathered and focused onto the sensor itself. So the dome shape is in fact the theory behind this. It can pick up approximately about 120 degrees of wide angle ray and channel it into the sensor pickup window. The module has a jumper setting to allow a single or multiple signal trigger. Now let's analyze the timing diagram given by the base chip data sheets. Now on the left is the re-triggerable mode. The yellow shaded area is a portion that the motion is enabled. Now this is controlled by the VC pin. The signal trigger, as denoted by the VS pulse, will enable the TX timing. The output will on for durations of a TX. Now after this, any signal trigger will be inhibited or disabled for a period of TI time. So even though there's a signal input, it will be discarded. So upon the completion of the TI time, the module is ready for the next input. With the first trigger, the output will be turned on. So if the second trigger comes in within the TX period, the output turn on time Tx will be restarted. With the third trigger, the Tx time restarted again. Now, if the fourth trigger comes in with the VC disabled, this trigger will be ignored. So the Tx period will continue, and then the Ti inhibit period will start. So as a summary, as long as the motion is repeated before the Tx time turn on expiry, the turn on time will be prolonged until the motion stops. This is how you can use this mode to capture valid motions. On the right is the non-triggerable mode. The first trigger, right, will enable the output turn on time. The second trigger will be ignored in this mode, even though it comes in within the Tx time period. The third trigger, right, will be ignored. So in this case, the output will be just turned on for duration of the Tx time. So this mode is good to capture first motions and ignore subsequent motion during the output turn on time. So in summary, both modes differ in terms of the way they capture the motions. So the first non-triggerable, in the summary, it will be just continue turn on until the motion stops, while the right side here, the non-triggerable mode, will just capture one motions and then it will just ignore subsequent motions. Now let's observe a video that shows you where's the best place to observe the module output. Okay, this video we try to display the module output on the scope by tapping on the pin number 12 of the IC output. Now before we can actually do all this testing, we have to actually connect a wire to pin number 12 of the operation amplifier output. Okay, this is where I already soldered a wire onto the IC pin number 12. Now once I've done this, then I will connect this wire to the oscilloscope, one channel, whereby the channel output right now is running on another module already connected. You can see there's a yellow line running around, because even without any detection, there will be some background infrared signal. Okay, now the module has been covered up with something here. There's another casing, so it won't detect me. Now let's observe another video that shows you two different brands of the same module type. You will notice they differ in performance due to the bit chip as well as the pyroelectric sensors. Now the yellow channel is actually the PIR number 1 output. Now if I do not make any movement, okay, if I just stay unmoved, you can see the PIR captures some noise, right? You can see there's some zigzag noise around here, whereby you can see the second brand, right? The signal is almost smooth and stable, right? It doesn't really have that kind of sawtooth. Now the cursor here, in fact there's two cursors. You can see there's one upper and one down. You try to indicate that the PIR will actually show a signal rise whenever it detected a motion, right? So now the signal actually can rise or can actually fall. It depends on the sensor within the PIR. Now no doubt the PIR only have one sensor, but it has built-in sensor A and B inside. Alright, so if sensor A or B, whichever bigger, the signal may be like what you see on the scope here, right? It may swing up, right, or it may swing down. So it really depends on whether you move left or move right, or whether the sensor A or B inside detected the direction of your motions, right? So you can see it's up and down like that. Now let's observe another video whereby I stand 6 feet away and do a horizontal motions. I shift to my left, right, it can trigger. I move to my right again, alright, this can trigger. So the next video will show you what happened when I stand 8 feet away. Now I stand about 8 feet away, right? I will do a horizontal shifting to my left. Right? So we see it can't trigger. So I try to move to the right again, it still can't trigger. So the next video here will show you the scope images when I move backward. So now I just move backward, you can see how the output changes. So choosing a good module is not an easy task. There are so many modules carrying the same brand but varies in performance. The only way is to check the behavior of the module sample and get your supply from the same supplier to ensure you will get the same batch of goods. So that's the end of this sharings. Have a nice day. Thank you.